Howdy, this is the Electrostatics Basics Review for AP 2. Electrostatics is something that we discussed last year in AP 1 or regular physics. And so we did talk about electroscopes, but we're going to go over it real quick so everybody can have a great reminder. Alright, the basics, first of all, that I would do is definitely play this video and watch it and then listen to the information. Okay, so just pause this video and click on that and then listen to it. Hopefully if you have the same charge, which is demonstrated in the video, then they're going to repel each other. If they have opposite charges, they're going to attract. So what would you believe that these would do? Hopefully you would say repel, since both of them have a positive charge. So, the law of electrostatics, whoops, we're going to pause that. The law of charges roughly states that the law of charges is that like charges will repel and unlike charges will attract each other. This is also known as the first law of electrostatics. Now, what is a charge? Classic charges are when rubbed rubber is going to be rubbed with wool or fur and result in a negative rod. Now, a glass rod that's going to be rubbed with soap will result in a positive rod. Consider four charges, A, B, C, and D, which exist in a region of space. Charge A attracts B, but B repels C. Charge C repels D, and D is positively charged. What is the sign of A? We have to think about this as positives and negatives. So, we say that A and B, A is going to attract B, but B is going to repel C, and C repels D, and D, we were told, was positively charged. Well, if C and D repel, then that means that D also must be, or that C must also be positive. And if B and C repel, then that means that B also must be positive. But if B and A attract, that means A is negative. Consider the two charged spheres of equal size, carrying a charge of +6 coulombs and -4 coulombs, respectively. The spheres are brought in contact with one another for a time sufficient to allow them to reach an equilibrium charge. They're then separated. What is the final charge on each sphere? Well, the thought is that if we have a +6 and a -4, what's going to happen is we're going to end up with only being able to have a total of a +2 overall. So if they're going to have a +2 overall, then that would mean that this one would be a +1 and this one would be a +1. Because when we have +6 coulombs plus a -4 coulombs, the overall charge that exists here is a +2 coulombs. So the only thing that we can do is transfer charge until everything is equal to +2. So each one would get a +1 charge. A material can be an electric insulator or it can be an electric conductor. Insulators, remember, are materials that are going to hold electrons tightly together. And these are going to, there's no such thing as a perfect insulator, but some really good ones are glass, rubber, plastic, and dry wood. Now, conductors are going to allow electrons to move freely. And again, there's no perfect conductors, but really good ones are metals, such as silver, copper, gold, and mercury, which are also transitional metals because they have different charges, and that's because they allow the electrons to move more freely than the other ones do. Objects can become charged in 3 ways, and we talked about these as friction, where the electrons are rubbed off. Remembering that with electrostatics, the only thing that gets to move are the electrons. Protons are stuck in the middle of the nucleus. And then induction is when you charge an object without actually touching it. You just get it near another charged object. And then conduction is charging by actual contact. You're going to touch a charged object to another charge or another object and charge it. Now, when you charge by contact, you take an uncharged electrosphere like we have here below, and you're going to bring a negatively charged rod into contact with that knob. Some of those negatives are going to go into the electroscope. When they do that, the electrons are going to move down onto the leads, and they're going to cause them to separate because they're like charged. So now they're going to repel. When the rod is removed, that charge is going to remain there because you actually transferred electrons to the electroscope. Now, charging an electroscope positively by contact with a glass rod would be doing it the same way, but instead you go near this uncharged electroscope and you would actually be pulling electrons from the knob into the rod. And so when you pulled electrons from the electroscope, it would now be left as a positive charge, and that positive charge would cause the leads to also then separate. When you're charging by contact, you need to remember that the electrons are the only thing that moves. So either you're transferring electrons from the rod onto the sphere or from the sphere onto the rod. So it's going one way or the other. But it's always going to end up as the same charge of whatever you touch it with. So if you touch it with a negatively charged object, then what you're charging is also going to be negative. If you're touching it with a positively charged object, then what you're charging will actually become positive as well. Now, induction for a single sphere, when you have an uncharged sphere, what you're going to end up creating is polarization. You're going to cause the charges to separate on that sphere, and when you bring a negatively charged rod to it, because the negative charges are going to want to get as far away as possible. So this is polarization. Now, if you allow for those electrons to somehow escape by grounding it, then you will leave that charged by induction as an oppositely charged object now than what you brought towards it. So we brought a negatively charged object near it, but once we went through polarization and grounding, then we ended up with an oppositely charged object. This is what induction is when you have polarization and grounding. Otherwise, if we had just stopped here, then we would just end up with polarization. And then when we moved away, which would just be a temporary charge, then when we took the negatively charged rod away, it would just go back to being this uncharged sphere. When we're charging two spheres by induction, we have uncharged spheres, and the electrons are going to get as far away as possible from this negatively charged rod. So this is a more distinctive polarization since the objects are touching each other, and they can travel that way. So we get a separation of charge, or a polarization of the two objects completely. Then when we pull the objects apart, we've now isolated those charges. So all the negatives or more of the negatives are on the far right, and more of the positives have stayed on the far left. So we would end up with oppositely charged objects. So again, you can do it in both ways, either by with grounding and polarization, or just polarization and then pulling the objects apart. Now, grounding is allowing the charges to move freely along a connection between a conductor and the ground. The Earth is an infinite reservoir of electric charge, so lots of times we pick it up, we move it around, it goes back to the ground. And this is what happens when you shock yourself. You grab onto when you've walked across carpet and you grab onto a doorknob, and it actually shocks you. You're just picking up electrons and transferring them from one place to another. And then you're not allowing them to go backwards to the ground. So you're a great grounding wire, because electrons will flow through you very easily into the ground. So to review, a negatively charged object is brought near a neutral conducting sphere. Okay, so the particles will then separate. The electrons will move to the opposite side. If you bring in a grounding wire, those electrons will escape because they want to get as far away from this negatively charged rod as they can. And then, after you've allowed those electrons to move out of the sphere, if you take that negatively charged rod away, you end up with an oppositely charged sphere. So induction always results in an oppositely charged object, and conduction always results in the same charge. Hope this helps as a quick reminder of electroscope basics.